All right, welcome to section 10.1. In this chapter, we are going to be looking at three-dimensional points along with some vectors. In this section here, we're going to show you how to graph a three-dimensional coordinate and also find the distance between a couple and also midpoint. All right, we've got here are some definitions or some things that you should want to go ahead and use your note packet and fill in the information. Previously, we have worked in a two-dimensional plane. It's called the Cartesian plane. We also refer to that as the XY coordinate plane. We will now add a third axis. It's the z-axis, and this axis is perpendicular to the XY plane. This new coordinate system is called three-dimensional coordinate system, and the point in this system are represented by an ordered triple x, y, z. Here's what your coordinate system is going to look like. The three-dimensional coordinate system is divided into octants, and octants are each of the sections, and there are 8 total. To give you an idea of one octant, let's use the octant right here. So I'm going to go ahead and draw this box in. This is an octant right here, this portion. And you can see this is on the upper right hand side, and so you have 8 of those going all the way around this figure. Here's another one, just so you get an idea. We have one that comes this way as well. This front one. So you have to think in depth perception here. This box, so this is the front half, back half, and then you have 2 on the bottom, and then you have the full left side over on the other side. Here's the left side. That's the left side. Anyway, if you can see visually like three-dimensional, this will be pretty easy for you. All right, here's what we've got. How to plot points in 3 dimension. So this first one here, what you want to do is you have to know where your axes are located. And this is your x-axis right here. And the coming towards us is the positive x-axis, and going behind us is the negative x-axis. Okay, your y-axis here is on the side, so this is your positive y, and then your negative y is going away from us. And then your z-axis, this is the positive z-axis, and then going down is the negative z-axis. To plot points, you need to do all 3 of these coordinates, but yet what you're trying to create is a 3-dimensional location. So it's easy and nice to be able to create a box to show where your point is located. So first let's do the point 3, 2. 3, 2, I would come out 3 units on the x and then over 2 on the y. But what we need to do is make a rectangular region, and you can do that by drawing parallel lines to both the x and the y axis. So this is the intersection between 3 and 2. Now we have to go up 3 units. If I go up 3 units on the z, then what I want to do is I run a line that's parallel here to my x-axis and parallel to that y-axis, and we're trying to just make this box. And once you can create this box, then that is this is my x and y location, and then going straight up from that, so there's the point right here. That is your point. So try to create a 3-dimensional rectangular prism, and you'll be able to get your location. Get rid of some of this. So there's your first point, and we'll do the same thing for the next point. All right, so we are going to do -2, -1, -3. So -2 would be back 2 units. -1 is to the left, so here's this little location for x and y. And then down 3 units. I need to go down 3 units, and what I would do is create that same little rectangular box. And what you can do is always run parallel. Always run parallel to your x and y axes. And then down 3, so this would be the corner, the back corner of that box. All right, let's try the next one here. -4, +4, and 1. So -4 would be back 4 units. And then to the right 4. So again, I'm just going to run parallel lines to both the x and y axis. And then up 1 unit. So up 1 unit, this would be my rectangular prism here. So up 1 unit would be right there. Here's my point. So you go back 4, right 4, and then up that 1 unit. There you go. Those are the 3 ordered triples, and that's how you would plot your points. The next thing we're going to look at is the distance formula, and the distance formula really is followed by our distance formula in 2 dimensions. We just have to include the third component of our ordered triple with the formula. So it's still x squared, or x to the subscript 2 minus x1 squared plus y sub 2 minus y1 squared, and then the third part to it, the z's. Let's go ahead and use that distance formula. So distance equals the square root of 5 minus 2 squared plus 6 minus 4 squared plus 2 minus -1 squared. This is the square root of 3 squared, which is 9, plus 2 squared, which is 4, plus 3 squared, which is 9. So the distance between the 2 ordered triples is the square root of 22. We also are going to look at midpoint, and the midpoint between 2 points follows the same midpoint formula. We just have to add this third part to it. So midpoint is where you add x plus x divide by 2, add y plus y divide by 2, and then your third part. So this is the midpoint between 2. The midpoint is like finding the average. It's the middle. Let's find the midpoint here. So we've got midpoint equals 2 plus 6 divided by 2, comma, -3 plus 0 divided by 2, and 1 plus 3 divided by 2. I'm just substituting the x's in, the y's, and then finally the z's. And to simplify, that's going to be 8 divided by 2 is 4, -3 divided by 2 is -3 halves, and 4 divided by 2 is 2. And there's your midpoint between those 2 points. All right, so now I want you guys to try this one, and go ahead and pause the video and try to attempt the distance and midpoint, and then you can check your answer. All right, and these are your answers. Now you are going to want to go ahead and simplify any of your roots. All right, the last thing we're going to look at is finding the intersection between a sphere and talking about a sphere and their equations. But the intersection between a sphere and one of the xy or yz planes. But let's talk about a sphere first, and that is all generated from the circle equation. This is the circle equation where we have x minus h squared plus y minus k squared equals r squared. And remember, the h and k here is our center. Well, when we have a sphere, we just add that third component. So it's x minus h squared y minus k squared plus z minus j squared equals r squared. And the j here is the third part to this, and so that is part of the ordered triple. So the center is hkj. This equation represents the points on the surface of the sphere and not the points on the inside. So it's all the points on the surface. Let's write an equation. To write an equation here, we're going to put all three components in and set it equal to r squared, where our radius is 5, so r squared is 25. We have x minus 2, and then it's y minus 3, and z minus a negative 1 or plus 1. So that's the equation of the sphere, with this being the center and radius. We can also put our sphere in standard form by completing the square. And so when I complete the square here, on all three of them, I'm going to go ahead and group my x's together. I'm going to group my y's together. And I'm going to group my z's together. It doesn't look like I have to do any factoring. And I'm going to move my 2 to the other side. So this is what we have to do to complete the square. We are going to add half of 1 squared here. Add 1, add 1. Half of 6, 3, so add 3 squared, 9, add 9. And half of 4 is 2 plus 4. Plus 4. We can factor. This is x minus 1 to the second plus y plus 3 to the second plus z minus 2 to the second equals 16. And that is the equation of the sphere. So my center is 1, negative 3, 2, and the radius is equal to the root of 16, which is 4. All right, the last thing we're going to do is find what's called the trace. Finding the intersection of a surface, so sphere, with one of the 3 coordinate planes. The xy trace is a set of all points that are common with the surface and the xy plane. In other words, it's all the points on the circle. If you intersect a sphere with a plane, the intersection is a circle. And this is how you find it. Basically, if you're finding the trace, you will let one of your variables equal 0. It's the one that's missing from the trace. So if you're finding the xy trace, you let z equal 0, and so on. And by letting one of the values equal 0, what that's going to do is it's going to be able to rewrite our sphere equation into a circle. So let's find the trace here. Describe the xz trace, and when it means to describe it, that means to what's the equation of it. And I'm finding the xz trace, so that means I will let y equal 0. And if y is equal to 0, then this is what we have. We have x minus 4 squared plus 0 plus 3 squared is 9 plus z minus 1 squared equals 25. So solution is x minus 4 squared plus z minus 1 squared equals 16. This is the equation of the circle. The center is 4, 1 with radius of 4. And so that's how you can describe your trace. And there's your assignment for this first section.